Welcome back. One type of expression that you might write in Python is what's called a function call expression. So you can think of functions as boxes that contain some machinery inside of them. So I'm going to visually represent them here just using this gray box. And you can think of a function as something that takes in some inputs. So here the inputs feed into the top here, and then these inputs go inside of this machinery. This machinery does something with the inputs, and then after it's done its work with the inputs, it spits out an output. So visually again, you can think of it as working something like this. So here we have a function. It takes in 3 inputs or arguments, and then it does some work, and then it spits out an output or return value. So let's watch that again. So again, we have the function, and it takes in 3 inputs here or arguments, then it does some work, and then it spits out an output or a return value. Now let's translate this visual metaphor into actual working Python code. Here's an example of how we would actually write a function call expression in Python. Suppose that we have a function named square, and our square function takes in 1 argument, which is going to be a number, and then it returns or outputs whatever that argument is squared. So for example, if we say square and then open parentheses, and we put our argument in between the parentheses here, so this is called calling the square function with 4 as an argument. So this is how we actually write that in Python. Again, we say square or whatever the name of the function is. Then inside of parentheses, immediately after the name of the function, we pass in our arguments. So the arguments go here. And then the value of this overall expression, so whatever the value of this expression is going to be the return value. And so in the case of square, if square squares whatever input or arguments you give it, then the return value is going to be 16. And this is what it looks like when we translate this Python code into that visual representation that I just mentioned. So we have the square function, again represented as a box. And the square function, in this case, we suppose that it takes in 1 input or argument, and if we pass in 4, it does some work, and it spits out an output or return value of 16. To watch that again, we pass in 4, the square function does some work, and it computes an output or return value, in this case, of 16. And again, this is how we write that in Python code. We say the name of the function, square, then open parentheses to say that we want to call that function, and then in between parentheses, then we pass in whatever arguments we want our functions to take. Now, Python functions can take 1, 2, or any number of arguments or inputs, but there's always exactly 1 output. So for example, here this function takes in 3 inputs or arguments, but it spits out 1 return value. So again, functions always take any number of arguments, but there's always 1 value of that function call. So let's look at a little bit more Python code on calling functions. So here on the first line, we're actually calling 2 functions technically, because here print is a function that we're calling. And we're passing in as an argument to print an expression which just so happens to be another function call. And this function call uses the square function that I just described. So again, the square function that I'm describing, this isn't a built-in with Python. This is something that we defined for the purpose of explaining function calls. But we defined it in a way that it takes in 1 argument, in this case square 3, and then it spits out that number squared. So if we say print out the value of square 3, then this is going to print out the integer 9. So let's see that in action. So I'm going to comment out the rest of these lines and run my code. And I can see that the value of this expression, square of 3, is 9. If we call a function but we don't have a print statement, so let's suppose that I say square 5, the value of this expression is going to be 10, but you'll notice when I save and run my code, it's not going to actually affect the output. And that's because we never actually printed the value of square 5. We just computed the value of square 5. excuse me, it's not 10, it's 25, of course. So here, the value of this is 25, but we never print out its value. Now, let's suppose that we have another function called sub. So sub takes in 2 arguments. So I can represent that visually like this. So it takes in 1 and 2 arguments. And just like every other function, it's going to spit out 1 return value. Now, let's suppose that sub subtracts the second argument from the first argument. So in other words, suppose if I passed in 6, and 4, then my sub function is going to spit out 2, because 6 minus 4 is 2. So we would call the sub function by saying print out and then sub. And then here you'll notice that we have 2 arguments, and we separate those arguments by a comma. So we print out the value of sub 6 and 4. And we see that the value of this expression, sub 6 and 4, is 2. If we call that again, so if we call sub with arguments 5 and 9, then this is going to give us -4, because 5 minus 9 is -4. We can also combine function calls with other operators, including function calls. So here, if we print out the value of square 3 plus 2, then Python is going to first compute the value of this overall expression by evaluating the value of square of 3, and then it's going to add the result of that to 2. So Python is going to compute the value of square of 3, and it's going to get 9, and then it's going to compute the value of this expression, which has the value 2 because it's a literal expression, and then it's going to add these numbers together to give us 11. Now, this expression on line 2 is much more complicated. So here we can see that we're calling the sub function. We are calling it with 2 arguments. So the first argument is square of 3. So this is arg1. The second argument is square of 1 plus 1. So this is arg2. Now, whenever Python calls a function call expression, it needs to figure out what the values of the arguments are. So Python kind of computes the values of a function call expression from the inside out. So it's going to go from the value of 1 plus 1 to the value of square 1 plus 1, and then the value of square 3. And then after it has the values for square 3 and square 1 plus 1, it's going to subtract those 2 values by calling the sub function. So again, we're kind of going from the inside out to the next layer, and then out to the next layer beyond that. So when Python computes this, it's going to first compute the value of square 1 plus 1, or 2. So it's going to compute the value of square 2, and that's going to give us 4. It's going to compute the value of square 3, and that's going to give us 9. And then it's going to compute the value of sub when called on 9 and 4, and that's going to give us 5. So if I run my code, you'll see that we get 11 from line 1 and 5 from line 2. Just to run through the exact steps that Python takes when computing the code on line 2, Python first computes what's the value of square 3, it gets 9. Then it computes what's 1 plus 1, and it gets 2. Then it computes what's square of 2, and it gets 4. Then it subtracts 9 and 4, and gets 5, and that's what it ultimately prints out. Now, one thing to note is that functions are objects in Python. So if I print out what's the value of square, then Python is going to tell me that square is a function. So if I run my code, you can see that line 1 prints out function square. In order to actually call the function or run that machinery, we need to have the name of the function, and then open parentheses, and pass in our arguments inside of those parentheses. So in other words, we need to have open parentheses right after the name of the function in order to say that we want to call the function. We don't want to just reference the function object itself. That's all for now. Until next time.